Hello and welcome to this revision session for GCSE Combined Science Physics Paper 1, covering the topics which come from the 2022 examination paper. So in this revision session we're going to look at answering questions on GCSE Physics Paper 1. So if we've been successful and we've learnt in today's lesson, we can answer GCSE Physics examination style questions, assess our understanding on GCSE Physics and understand what topics we need to improve upon for GCSE Physics. So how do you carry out this revision? Well, when you're doing this work in this revision session, divide your piece of paper into two sections. Make the section on the left hand side larger than the right hand side, and on this section write out your working out or answers to the questions in the revision session. When you're doing this, make sure you write out in full sentences and show your full working out. So in this section, write down any piece of information which you find useful or any hints and tips on answering questions from this revision session. And at the end of the revision session, write up these notes into a revision sheet for you to use independently. So let's have a look at some of the questions which are all based on topics from GCSE Paper 1 for Combined Science in 2022. So let's have a look at energy. So figure 5 shows a wood-fired hot tub. Describe the changes to the stores of energy of wood, pipe and water as the water is heated. So pause the video now, then unpause the video when you want to go through your answer. Well, it's very important that you talk about how the energy stores change and look at the diagram given to you. So the first thing to note is that the wood is burning, it's heating up the pipe which is heating up the water. So you say that the chemical energy store of the wood decreases because the energy is leaving the wood and going into the pipe. That causes the thermal energy of the pipe to increase, which will cause the thermal energy of the water to increase. The next question says the temperature of the water reaches 42 degrees Celsius. So the temperature then stays constant even though the fire continues to burn. Explain why the temperature of the water stays constant. So pause the video now, then unpause the video when you want to go through your answer. Right, so you've got to understand that in any situation energy is dissipated to the surroundings, but because the temperature of the water is staying constant, it's telling us that the thermal energy store of the water is staying constant. So whilst energy is being dissipated to the surroundings, it's at the same rate as which energy is transferred into the water. So therefore the total energy in the water is staying at a constant rate. The next question shows us that figure 9 shows a sketch graph of how the maximum tendon length during a jump changes with the speed of a kangaroo. So explain why a kangaroo can jump higher as its speed increases. So pause the video now, then unpause the video when you want to go through your answer. Right, it's important to note again that the length of the tendon will stretch as the kangaroo is jumping up, so therefore the tendon is extending. The longer the length of the tendon, the greater the extension. So if an object is extending, what energy store is increasing? Well, the elastic potential energy store is increasing because elastic potential energy is the energy stored due to an object extending. And this energy is then transferred to the gravitational potential energy store, which will allow the kangaroo to jump higher. The next question says a kangaroo has a maximum gravitational potential energy during one jump of 770 joules. When the kangaroo lands on the ground, 14% of the maximum gravitational potential energy is transferred to elastic potential energy in one tendon. The tendon has an unstretched length of 35 centimeters. When the kangaroo lands on the ground, the tendon stretches to a length of 42 centimeters. So calculate the spring constant of the tendon. So pause the video now, then unpause the video when you want to go through your answer. Right, so in this type of question it's important that you know what equation you're using, and that is elastic potential energy is equal to a half times by spring constant times by extension squared. Now how do you work out extension? Well, it's the stretched length minus the unstretched, so it's 42 centimeters minus 35 centimeters, but you've got to convert centimeters into meters, so our 7 centimeters becomes 0.07 meters. We then also know what's our energy. Now it says 770 joules in the question, but it says that only 14% of this is actually transferred in the situation. So you've got to actually work out 14% of 770. So you do 770 times by 0.14. So that's 107.8. Now the next thing you do is you substitute these values into your equations. You say 107.8 is equal to a half times by spring constant times by extension squared, which is 0.070. So that's the first mark, and always in any equation equation, directly substitute the values into your equation. You then rearrange it and make K the subject, and then you work out our answer to be 44,000 newtons per meter. The next question says, electrical generators can provide 1.5 times 10 to the 9 watts of power for a maximum of 5 hours. Calculate the maximum energy that can be transferred by the electrical generators. So pause the video now, then unpause the video when you want to go through your answer. In answering this question, you've got to look at your equation sheet, and it tells us that energy is equal to power times by time. Now you're given the power in the question and you're given a time, but you're given a time in hours and it should be in seconds. So you need to convert your 5 hours into seconds by doing 5 times by 60 times by 60, because there are 60 seconds in 1 minute and 60 minutes in 1 hour. So our time is not 5 but it's 18,000. So you do 1.5 times by 9 times by 18,000 is 2.7 times 10 to the 13 joules. The next question says that figure 11 shows a battery operated drill. When the drill is turned on, the drill bit spins round. Describe the energy transfers in the drill when it's first turned on. So pause the video now, then unpause the video when you want to go through your answer. Now when you're describing energy stores, always talk about the starting energy store and how it's decreasing, then the final energy store and how it's increasing, and then that some energy is always transferred to the internal energy of the surroundings or dissipated. So we say here it's a battery, so it's chemical energy. So the chemical energy of the battery decreases. The drill bit is spinning, so it's moving, so its kinetic energy store increases whilst the thermal energy is dissipated to the surroundings. The next question shows that figure 2 shows some students playing a game of basketball. During the game, the players bounce the ball off the ground. So describe the energy changes that occur when the ball hits the ground. So pause the video now, then unpause the video when you want to go through your answer. So like we said before, we talk about our starting energy store, and it's starting with the ball moving downwards, and that decreases, so kinetic energy store decreases. Then talk about what stores increasing, and that's the fact that when the ball hits the ground it changes shape, which is the elastic potential energy store, and that some energy is always dissipated to the surroundings. The next question says that figure 14 shows a football player kicking a ball towards the goal. The goalkeeper is trying to stop the ball crossing the line. After being kicked, the ball has a speed of 20 meters per second. The mass of the ball is 450 grams. Calculate the kinetic energy of the ball. So pause the video now, then unpause the video when you want to go through your answer. So if you look on your equation sheet, you'll see that kinetic energy is a half times by mass times by velocity squared. So to get your first mark, you've got to directly put the numbers from the question into the equation. But do remember that we don't work in grams in physics, we work in kilograms. So 450 grams turns into 0.40 kilograms. Pop the numbers in, you work your answer through to then be 90 joules. The next question says, when a force is first applied to a piece of wire, the wire behaves like a spring and stores 2.25 times 10 to the minus 3 joules of elastic potential energy. Calculate the extension in the wire, give your answer in millimeters, and the spring constant is 2,000 newtons per meter. So pause the video now, then unpause the video when you want to go through your answer. Well, this is a very challenging question, but what you've got to do is you've got to work out what your equation is for elastic potential energy. And elastic potential energy is equal to a half times by spring constant times by extension squared. So what you should be doing is then substituting your numbers in. So you would say 2.25 times 10 to the minus 3 equals a half times by 2,000 times by extension squared. That's always gets you your first mark by directly substituting your values into the equation. You then will rearrange it and make extension the subject, and then you work out your answer to be 0.0015 meters. Now the answer wants it in millimeters, so you then got to convert that into 1.5 millimeters. The next question says the power of a kettle was 2.6 kilowatts. The kettle took 120 seconds to heat from 0.80 kilograms of water from 18 degrees Celsius to 100 degrees Celsius. Calculate the specific heat capacity of water using this information and give your answer to two significant figures. So pause the video now, then unpause the video when you want to go through your answer. Right, so how do you answer this particular question? So you look on your equation sheet and you see that energy is equal to mass times by specific heat capacity times by change in temperature. So you firstly work out your change in temperature of 100 minus 18. So you'll get your answer be 82. You've got a mass but you don't have an energy, but you do have a power into time. Now you've got to remember that energy is equal to power times by time. So you would do 120, as that's the time in seconds, multiplied by the power, but we don't work in kilowatts, we work in watts, and we convert from kilowatts to watts by times and by 1,000. So therefore it's 2,600 times by 120. That gives our energy to be 312,000 joules. We then substitute the values directly into the equation, so it's 312,000 equals 0.80 times by C times by 82. We then rearrange it, make C the subject, and we get 4,756. But it wants it into two significant figures. So you do 4800. Why is that? Well, you're going to have 4 digits in there because there are 4 digits before the decimal point, but only the first two go into significant figures, so it's 4 and 8 because 4,756 rounds to 4,800. The next question states that a different washing machine transfers 380,000 joules during a washing cycle. 65% of the energy transferred by the washing machine is used to heat the water from 11 degrees Celsius to 30 degrees Celsius. The specific heat capacity of water is 4,200 joules per kilogram degree Celsius. Calculate the mean mass of water heated by the washing machine. Give your answer to two significant figures. So pause the video now, then unpause the video when you want to go through your answer. Right, so because it's a 5-mark question, it's going to want you to do two different calculations. And the first calculation is that not 380,000 joules of energy will be used, rather that 65% of that will be used. So the first thing to do is to multiply 380,000 by 0.65, and that gets you 65% of the energy used to be 247,000 joules. We can then substitute it into our equation with specific heat capacity, which you are given in your exam. So we say E equals MC triangle T, and then you sub your values directly in. So it's 247,000 equals M times by 4,200 times by 19, which is our change in temperature. Goes from 11 to 30. We then rearrange it, make M the subject, and we get M to equal 3.095 kilograms. It wants to be two significant figures, so 3.095 is equal to 3.1 kilograms. The next question says a cooling station has a power of 315 megawatts. It cools water from 12 degrees to 7 degrees. Calculate the mass of water that the cooling station can cool each second. So pause the video now, then unpause the video when you want to go through your answer. Right, so how would you answer this question? Well, again, energy is equal to mass times by specific heat capacity times by change in temperature. Now, again, what's the change in temperature? It's 5 because it's 12 to 7, so the change is 5. So we can therefore work out what our energy is. Now, energy is power times by time, so the time is 1 because it's 1 second, but the power is 315 million, or 315 times 10 to the 6, because it's in megawatts, not watts. So to work out your energy, it's 315 times 10 to the 6 times by 1. Then directly substitute the values into the equation. So we say 315 million is equal to mass times by 4,200 times by 5. You then rearrange it, make mass the subject, and mass equals 15,000 kilograms. The next question says, figure 9 shows a theme park ride called the Aqua Chute. Riders of the Aqua Chute sit on a sled and move down a slide. So the first question says the decrease in the gravitational potential energy of one rider is 8.33 kilojoules. The rider moves to a vertical height of 17 meters. Calculate the mass of the rider. And at the bottom of the slide, all riders and sleds have approximately the same speed. Why? So pause the video now, then unpause the video when you want to go through your answer. Now the first question is linking it into the gravitational potential energy equation, which you are given in your equation book. So you say that gravitational potential energy is equal to mass times by gravity times by height. So you then pop in your values from your equation directly. So that gets you your first mark. Now it's 8,330 because 8.33 kilojoules is actually 8,330 joules is equal to mass times by 9.8 times by 17, which is the change in the height. We then rearrange our equation, as you can see on the screen, and make m mass the subject. You then work a value out to be 50.0 kilograms. Now the next question is asking why they all have the same speed. Well, it's all about looking at the question, because the question says they're starting off with gravitational potential energy and they're turning into kinetic energy. So we can therefore say that a half mv squared is equal to mg. So our decrease in gravitational potential is equal to our our increase in kinetic. So if you look at the equations, the mass cancels out in both sides. So therefore the speed will only depend on the height, and because they're all starting at the same height, they'll all have the same speed. The only differences will be due to variations in air resistance and friction, or if they have a different speed at the direct start. So it's always important you look to see what our energy stores are and how they equate to each other. Let's now have a look at some questions of electricity on topics that will come up on the 2022 examinations. So the first question says the electric motor in a car is powered by a battery. To charge the battery, the car is plugged into a main supply at 230 volts. The power used to charge the battery is 6.9 kilowatts. Calculate the current used to charge the battery. So pause the video now, then unpause the video when you want to go through your answer. So for this question, it's all about reading the equation sheet and looking at what equations we have. So we know that power is equal to potential difference times by current, which is what we want to work out. So we substitute our values directly into that. But again, we're given power in kilowatts, so we've got to convert our kilowatts into watts. So 6.9 kilowatts becomes 6,900 watts. So it equals 230 times by I, make I the subject, and it equals 30 amps. The next question says, a gas-fired power station has a power output of 50 megawatts. Calculate the energy transfer during 24 hours. So pause the video now, then unpause the video when you want to go through your answer. Right, again with this one, it's all about using your equation sheet. We know that energy is equal to power times by time. Now for this question, we don't use time in hours, we don't use time in minutes, we use time in seconds. So you convert your time in hours into seconds by multiplying by 60 by 60, so it's 86,400, and we turn our power from megawatts into watts by saying mega is times 10 to the 6 or million. So it's 50 million times by 86,400 to get our answer to be 4.32 times 10 to the 12 joules. Always check your units in an equation. The next question says a person watched television for 2 hours. The power rating was 0.40 kilowatts. Give the energy transferred by the television, give your answer in kilowatt hours, and the cost of electricity is $0.12 per kilowatt hour. Calculate the cost of electricity used in the 2 hours. So pause the video now, then unpause the video when you want to go through your answer. Now in this one you might say, do we convert our power into watts and do we convert our time into seconds? Well, we don't, because it asked in the actual question to give it in kilowatt hours, so you can just keep them in kilowatts and hours. So it's 0.4 times by 2 is equal to 0.80 kilowatt hours. Then to work out the cost per kilowatt, cost in total is the cost per hour is 0.12. We know we've used 0.8 hours, so we just multiply the two numbers together and we get our answer to be $0.096. The next question says the power rating of the drill is 21.6 watts. The potential difference of the battery is 18 volts and the drill is turned on and a charge of 30 coulombs flows through the battery. Calculate the time for which the drill is turned on. So pause the video now, then unpause the video when you want to go through your answer. Right, for a 5-mark question, it's going to be asking you to do two equations, and the two equations are as follows. Energy or work done is equal to potential difference times by charge, and that power is equal to energy over time. Now how do I know to use those equations? Well, look at what I've been given in my question. I've been given charge, potential difference, and I've been given power. So I've got to use equations with those terms in it. So the first thing we say is energy is equal to charge times by potential difference, so 18 times by 30. So we get 540 joules. We then say power is equal to energy over time. So we pop our numbers in and say 21.6 equals 540 over t, substitute the numbers directly in to get your marks, then rearrange it, make t the subject, and then you work out your answer through to be 25 seconds. We're now going to look at questions for the particle model of matter, and we're going to focus on topics which will be present on the 2022 examination this year. So the first question says, the area also contained a small amount of argon. As the temperature of air decreased from 20 degrees to minus 190 degrees Celsius, the argon changed from a gas to a liquid to a solid. Explain the changes in the arrangements and the movement of the particles of argon as the temperature of the air decreased. So pause your video now, then unpause the video when you want to go through your answer. Right, with this type of question, it says explain. So you've got to explain what's going on. So what you've got to talk about is you've got to explain why things are happening. So you firstly describe what's happening and then explain what's actually going on. So as it's cooling down, the particles will slow down. So when it goes from a gas to a liquid, the particles slow down. When it goes from a liquid to a solid, the particles slow down. When the substance changes from a gas to a liquid, you can say the particles move from being very spread apart to being very close together and touching each other. When you go from a liquid to a solid, they're going from being freely moved to being fixed in position and going from a random arrangement to a regular arrangement. Now you then got to explain why that takes place, because when the temperatures decrease, and energy is being taken out of the substance, so we can therefore say the internal energy of the object decreases. So the kinetic energy of the internal goes down with temperature, and the potential energy goes down with or changes with the change of state. So therefore the forces between the particles will increase when it goes from a liquid to a gas, from a gas to a liquid to a solid, because they're now closer together. It's always important that you can explain what's happening in terms of change in temperature and change of state with internal energy. Remember that the temperature change links to the kinetic energy store of the internal, and the change of state links to the potential energy store of the internal. The next question says, a reservoir stores 6,500,000 meters cubed of water. The density of water is 998 kilograms per meter cubed. Calculate the mass of water in the reservoir. Give your answer in standard form. So pause the video now, then unpause the video when you want to go through your answer. Well, the equation, as you can check in the book, is going to be density as mass over volume. So the first thing you do is you pop your values into your equation. The second step is to rearrange it and to make mass the subject, as shown on the screen. You then get your answer through, then it wants it in standard form. Now standard form means it has to be a number between 0 and 9.9 times by 10 to the whatever value. Okay, so we can see here that the number between 0 and 9.9 is going to be 6.487, and that, if you look at how many zeros it will be 9 zeros, because it's going to be 9 values before you get to your decimal place from 6.4. So you can see it's going to be times 10 to the 9. The next question says here, okay, that describe the changes in arrangement and movement of particles as ice melts and turns to water. So pause the video now, then unpause the video when you want to go through your answer. Now checking, the key word here is ultra important, because it's not saying to explain what's going on, it's not asking to talk about the change in internal energy, it's just asking to describe, which is a much easier question. So you just have to describe what happens to the arrangement of the particles from ice to water, and the movement of the particles from ice to water. So we'd say that the arrangement is that the particles in ice are in a solid regular pattern, and the particles in liquid are in no fixed arrangement. But the movement is that in a solid they vibrate about a fixed position, but in water they are free to move because it's a liquid. The next question says, figure 5 shows a balloon filled with helium gas. Which statements describe the movement of gas particles in the balloon? So pause the video now, then unpause the video when you want to go through your answer. Right, it's very important that you can describe the movement of gas particles, and the things you've got to know, the just key facts are that gas particles move in a random direction with a range of a variety of different speeds. Now the temperature of a gas represents the average kinetic energy or the average speed, but gas particles move with a range of different speeds. The next question says, the temperature of the helium in the balloon was increased. The mass and volume of helium in the balloon remain constant. Explain why the pressure exerted by the helium inside the balloon would increase. So pause the video now, then unpause the video when you want to go through your answer. Right, it's important that you've got to understand what pressure is and what temperature is in terms of particles. So temperature relates to how fast the particles move. So if you've got an increase in temperature, you can say the particles have a higher speed, so a higher kinetic energy. Now pressure is caused by the particles colliding with the side of the object and exerting a force on the side of the object due to being a change in momentum. So what we would say is that if the particles are moving faster, number one, each collision with the side of the container has a greater force because they're moving faster, so there's a greater change of momentum, and also that per second there's going to be more collisions because the particles are moving faster. So we're exerting a greater force over the same area, so our pressure increases. We're now going to finally look at questions on the atomic structure topic, which are based on the topics on the 2022 examination on Combined Science Physics Paper 1. So the first question says a gold atom can be represented with as the following: 9779 AU. Describe the atomic structure of this gold atom, including the numbers of each type of subatomic particle. So pause the video now, then unpause the video when you want to go through your answer. Right, what you should be aware of is that the bottom number, the smaller number, is the number of protons in the nucleus, but for the atom it's the number of protons and electrons are the same. So the first mark is saying that you've got 79 protons but also 79 electrons, because the number of protons and electrons equal each other in an atom. Now we can work out the number of neutrons, because the larger number is the number of protons and neutrons, so the number of neutrons is 197 minus 79, so it's 118. Our protons and neutrons are in the nucleus, and the electrons are arranged in energy levels or shells around the nucleus. Don't say they orbit the nucleus, rather they exist in energy levels around them. The next question says that nucleus B decays by emitting an alpha particle. Draw an arrow on figure 7 to represent the alpha decay, and then say what is meant by the random nature of radioactive decay. So pause the video now, then unpause the video when you want to go through your answer. Right, so what do we know alpha decay is? Alpha decay is the release of an alpha particle, which is 2 protons and 2 neutrons. So that tells us that the atomic number is going to go down by 2 from 88 to 86, and the mass number, which is the number of protons and neutrons, goes down by 4 from 226 to 222. So you draw a line to 86 protons and a line to 222 mass number, so therefore that's our line for alpha decay. Now, what do we mean by the random nature of radioactive decay? You've got to understand what random means, and random means we can't predict which nucleus is going to decay first or next. Or you could say you don't know when a nucleus is going to decay. For a radioactive decay, we only know a certain number of nuclei will decay, not when an individual one will decay itself. And the next question shows us the polonium nucleus, and it decays by emitting an alpha particle and forming a lead nucleus. The lead nucleus then decays by emitting a beta particle and forming a bismuth nucleus. The bismuth nucleus then decays by emitting a beta particle and forming a polonium nucleus. Explain how these 3 decays result in the nucleus of the original element polonium. So pause the video now, then unpause the video when you want to go through your answer. Right, so it's important to know that you know what an alpha decay and beta decay do to a nucleus. So the alpha decay will cause the proton number to go down by 2, whilst 1 beta decay will cause the proton number to go up by 1. So 1 alpha causes the proton number to go down by 2, whilst the 2 beta decays cause the proton number to go up by 2. So overall, the number of protons in the nucleus has stayed the same, which tells you what element you've got, because the number of protons in the nucleus tells you the element of the atom. So because the number of protons remains constant, the element is the same. The next question says polonium-210 is a radioactive isotope that decays by emitting alpha radiation. Complete the decay for polonium-210 and explain why the contamination of the inside of the human body by a radioactive material that emits alpha radiation is highly dangerous. So pause the video now, then unpause the video when you want to go through your answer. Right, it's important to note that for any decay equation, the number before the arrow on the top must equal the numbers combined after the arrow on the top, and the same for the number below. So 210 is on top before the arrow, so the 2 numbers added up, 4 and another number, must add up to give 210, so it's 206. And then the same as 84 before, it's 2 afterwards, so what number you've got to add to 2 to get to 84? Well, it's got to be 82, so it's 206, 82. Now, why is contamination over a material that emits is alpha so dangerous? Well, the first mark is alpha radiation is highly ionizing. Now the second thing is you've got to talk about why that's important. Well, high ionization ability means an increased risk of cancer or organ failure or radiation poisoning or mutation of genes in DNA, which can lead to damage to cells and tissues in organs. So you've got to then say it will always be there, that effect, that damage will always be there until that radioactive material is removed from the body or excreted, or the activity of the material itself reaches the background radiation levels. It's important to note that any source that's emitting alpha radiation will always have this effect until it's excreted away from you. So, I hope you've enjoyed this particular revision session. If you've been successful in this revision session, you should be able to answer GCSE Physics examination style questions, assess your understanding on GCSE Physics, and understand what topics you need to improve upon for GCSE Physics. So I hope you've enjoyed this revision session on the Paper 1 topics for the 2022 GCSE Combined Science Physics Paper 1. Thank you very much for watching and have a lovely day.